This video will briefly show you how to do sequential regression, or sometimes it is called hierarchical regression. Sequential regression is different than simultaneous regression in so much that I end up running separate models where I add one independent variable at a time to see how it affects all the other independent variables and to see how much of the variance is explained by the addition of each independent variable. Here is my model. I want to predict classroom organization based on these 4 dimensions of class climate. I'm going to take 3 of my variables out. So they are here, NC, RSP, and TM. And I'm going to tell SPSS to enter in positive climate mean for the first block, or for the first model. It will do a simple linear regression between positive climate and classroom organization. I want to now add another variable in a separate model. So I'm going to add a negative climate. So SPSS will now run a model with both the previous block, positive climate, and the negative climate together. I can now see how the beta of positive climate changes in the presence of negative climate, and I can see how much unique variance negative climate adds to the model. Let's do this for the last 2. RSB, regard for student perspective, and BM, behavior management mean. Click paste. Run the syntax. And as I mentioned previously, we now have run 4 models. With model 4, we'll have the new variable in the model as well as the previous 3 variables added to it. Let's look at this. So the model summary. First of all, we can see that the first model, when we just had positive climate, accounted for about 61% of the variance, of an R-squared of about 61%. Adding in the second variable, negative climate, accounted for about 2% more. Adding the third one, accounted for about 5% more. And added the fourth one, did about 15% more, so quite a bit. And here is the coefficients. Here is model 1. Here is the beta for positive climate in model 1. It's 5.97. Here is the beta for positive climate in model 2. Notice it changed. It is now in the presence of negative climate. Here is the beta in model 3. It has gone down even further. It's becoming less and less important as these 2 other variables start competing for the same variance. And finally, look at model 4, where this variable, or this beta, is a lot smaller than the initial one, as these other measures compete for the same variance. And notice that the p-value also changes. In the first model, the beta for positive climate was statistically significant. That is true for model 2, model 3, and model 4, even though the p-value does go up a little bit. Is that true for all the other ones? Well, it bounces around. Negative climate has a p-value of 0.08 in model 2, and in model 3 it actually decreases, and in model 4 it goes up way high, indicating that behavior management is eating up or is competing for a lot of the same variance as negative climate. So this can tell you additional information of how the independent variables relate with each other as they compete for predicting the dependent variable.